Hi guys, welcome to Unit 8, Lesson 4, Slope and y-intercepts. So in this lesson they introduce y-intercepts as being also called the initial value, meaning like where does the graph actually start, okay? So that would be when x, or your input, is 0, which automatically makes it your y-intercept. They're also going to be talking about slope as the rate of change, which that's not necessarily a new concept. We just haven't used it a whole bunch yet, okay? So that's like from the starting point, how much is it changing as things go on, all right? And linear function, we've been working with that a little bit already. It's a function in the form y equals mx plus b, where m and b are both constants, okay? So again, it's a function that when graphed, it forms a line, right? And that's what we know as y equals mx plus b. So let's talk about some examples. Example 1 is also number 1 on your practice. Determine the initial value and the rate of change in the following description. At a local festival, the entrance fee is $12 per person, and ride tickets cost $2 for every ride. So in this case, the initial value, or the y-intercept, is going to be $12 because, and they might just want the number 12, maybe not the dollar sign. But that's your initial value because it's like, even when you've rode 0 rides, you still owe $12 just to get in, right? So that's your initial value. That's the initial cost to get in to the festival. All right, and if you didn't ride a single ride, that's how much you'd pay. The rate of change is 2, and let me check on there to see how exactly they wrote it, and they just want the number 12 and the number 2, okay? So the rate of change, right, because for every ride you ride, you pay $2 more, so that increases constantly, right? We talked about it being a constant rate of change, right? Rate of change. But depending on how many rides you ride, right? If you ride 6 rides, 6 times 2, right? 12 rides, 12 times 2. It's always going to be times 2. The second problem that we're going to talk about is number 3 on your practice. Determine the starting value and rate of change. So same thing, we're looking for the rate of change, that's our slope, and the initial value, that's our y-intercept. Now, we were given 2 points. One option would be go ahead and graph them and see what you find, right? But with the points that were given here, we weren't actually given our initial value, so we have to find it, all right? The first thing, though, that I'm going to find is my rate of change, because I can do that with 2 points without even touching a graph. Because remember, your slope is the difference in the y values over the difference in the x values. So what I could do, and what that means is I could take, I'm going to say that this is like problem number 2, and this is problem number 1. So I could take my y value from problem number 2 and subtract the y value from problem number 1. So that's my change in my y values. And then I'm going to put that over the change in the x values. Again, starting with 0.2, subtracting 0.1. Well, let's see. 8 minus 4 is 2. Nope, just kidding. Is 4. I was dividing in my head. Okay, is 4, and then 3 minus 1 is 2. Now, this reduces to 2, right? 4 divided by 2 is 2. So my rate of change is 2. You could also, we could write it as like 2 over 1 when we're thinking rise over run and things like that. But in the long run, our rate of change is 2. So now, using that information and one of these points, it doesn't matter which one I choose, I can plug those values in to the slope-intercept form equation, because then my only variable is going to be my initial value, or my y-intercept. So I just found m, that's 2, so I can plug that in. And then, like I said, we can choose either one of these points, it doesn't matter which one, to plug in for the y and the x. I'm just going to use the first one, 4 for y and 1 for x. And now I'm just down to one variable, so I can go ahead and solve for it. Well, 2 times 1 is 2, so let's see, 4 equals 2 plus b. Well, in order to get b by itself, I have to do the opposite operation. Right now I have a positive 2, so to get rid of it, I need a negative 2. I'm going to do that on both sides. 4 minus 2 is 2. 2 minus 2 is 0, so I'm just left with positive b. Now, in this case, they both happen to be the same, and that's okay. Sometimes that happens. All right? Now, with this next problem, this is number 4 from your quick check. I chose this one because it involved fractions. So it's the same process, same goal in mind. We're looking for what is the rate of change, which again, remember that's our slope, and our initial value, that's our y-intercept. Okay? So I have, just like the last problem, I have 2 points. So I'm just going to write them over here so I can see them a little better. We've got negative 4, comma 10 over 3, negative 10 over 3, and negative 1 and negative 4 over 3. So still the same process, there just happens to be fractions involved, which I know that can be a little intimidating. But we're going to be okay, I promise. So let's start with our slope, because with the information that we were given, we can find the difference between the y and the x values. Now notice the y-intercept, it's shown on the graph, but I don't know what it's equal to exactly. Okay, so we're going to use that same process that we did in the problem up above. Okay, let's start with slope. That's the change in the, oh my goodness, y values over the change in the y value, and over the change in the x values. Goodness, I'm getting tongue-tied. So, and it doesn't matter what order you do them in, just as long as you do it for both the y and the x. So I'm going to do, I don't know, I'll do negative 10 thirds minus, right, I'm looking for the difference between them, negative 4 thirds. Okay, so I did this one first in my numerator. I'm going to do this one first in my denominator. Negative 4 minus negative 1. Finding the difference between them, meaning subtraction. Now they both happen to be like a negative symbol next to a subtraction symbol, which means to add. So really I'm adding these. The bottom one, that one's a little easier, right? Negative 4 plus 1, that gives me negative 3. Okay? And then this one, they have the same denominator already, so that's good. That makes it a little easier to deal with, because really then I just need to focus on my numerator. Negative 10 plus 4 is negative 6 over 3. Well, lucky for us, that reduces, right? We've got 6 divided by 3 is negative 2. Okay? Now, and that, because that looks a little funny, right? Having a fraction inside of another fraction, but so luckily it reduced. Now I have a negative over a negative, which means it's positive, which is also good because this looks like it's going uphill, right? From when you look at it from left to right, it looks like it's going uphill, which means it's a positive association. So our slope would be 2 thirds. Knowing that, now I can go ahead and I can do that same process that we did before. Take our slope-intercept form, plug in values that we know. So let's see here. I'm going to do, well, we know we have 2 thirds for our slope. I'm going to do this one just because I like multiplying by ones. It's super easy, right? So that'd be multiplying by negative 1 plus b, and then it'd be equal to negative 4 thirds over here for the y value. So let's go ahead and work on getting the b by itself. Negative 2 thirds times negative 1 is negative 2 thirds. plus b. Well, if I have a negative here, I need a positive. I need to do the opposite, right? So they'll cancel over here and we'll be left with b. Now, I'm going to take this and bring it over here because I like to look at these horizontally. We have negative 4/3 plus 2/3. Well, again, we have the same denominator, which is good. We don't have to find a common denominator. But then we have negative 4 plus 2. That gives us negative 2. So our our y-intercept is going to be negative 2/3. And look at that. That makes sense, right? Because it's into the negatives, right? And it's a little bit before the negative 1. So I'm pretty confident in that answer. Okay? And again, these problems, they happen to have like the same value, just like how both of these ended up being 2. That's just coincidence. That's not always going to happen, okay? So, all right, guys, if you need extra support, as always, just let me know. Have a good day.